what I'm going to be presenting today is, gonna go over some things. If you're a Mastercam user, a lot of the things you're going to be looking at or seeing today is going to be very familiar. So the way we do toolpaths in the mill turn environment is really no different than the way you do milling and turning in standard Mastercam. Got the standard interface. I have a part here, just back from my old oil field days. Got a ball valve stem here, and we're gonna typically in the past, back when I was still a machinist, back in the last century, this would be done possibly like in 3, 4, maybe 5 ops. Take some to the saw, cut them off the size. Do a lathe operation on one side, lathe operation on the other. Maybe 1 mill op this way, another mill op on the 4-axis, stuff like that. So now we have these more advanced machines, and let's see if we can get this done all in one operation here. Get a part off here. So I have the parts already set up. I'm not going to go too much into the setup of the jaws and everything today. Just going to go ahead and focus on putting some toolpaths here and kind of show you how Mastercam kind of works. And the purpose of our demonstration today is to show the advantages. I'm gonna go ahead and turn off my turn profile here. What I'm gonna do is I'm gonna go ahead and start off by concentrating on the turning toolpaths for the left upper spindle. All right, so this machine that I have called up has upper turret, lower turret. We can machine on the left spindle, machine on the right spindle. So we're gonna turn all this part, turn the stuff on the right spindle, and then concentrate on the milling. So I'm gonna go ahead and start off with the facing operation. And I already have some 3D tools called up here. So I'm gonna start off with my axis combination here, upper left. I'm gonna pick this tool and just do a facing operation. I'm gonna make sure that I retract enough here. And I'll select OK to that. Then I'm gonna go ahead and do a roughing operation. I'm gonna start off from that chamfer back to this chamfer right here like this, making sure I don't hit my jaws. I'm gonna pick the same tool and go ahead and make some settings here. I'm gonna go ahead and lead out. I'm gonna extend the end of my cut 100 thousandths. I want to prep this chamfer, so when I do the second op, it cleans this up pretty clean here. So select OK to that. And then we'll say OK to the whole thing. And then I have that turn toolpath. Now, because I have an upper and lower turret, I can do a pinch turn. So with pinch turn here, I'm going to switch over to my lower left. My tool's going to update. I've got this one already set up. So for my presentation, and this is what I recommend when we're doing setting up libraries for customers, LL lower left, LR lower right. All these tools have prefixes on them. I'm going to go ahead and do a balanced turn for every pass for the only roughing operation I have. But there was multiple operations, and you could pick which one you wanted to sync up with. We'll select OK to that. And now we have a pinch turn here. So just like that with 3 operations, actually, you know what? I need to finish this tool. So I'm gonna go ahead and do a finish pass. Go ahead and select that chamfer to that chamfer right there. I'm gonna pick this tool right here. And this time I'm gonna allow it to do a plunge cut so I can handle that little undercut right there. We got that little undercut. And again, with my lead in, lead out, I'm gonna extend the back side of the contour 100 thousandths. And I'll select OK to that. All right. So just like that, in 4 little simple operations, I've finished all the turning for the left spindle. All right. Now let's concentrate on this side over here. I'm going to go ahead and do a facing operation. I'm going to pick my lower right. And I have a lower right tool right here. See, lower right. And it recognizes and it knows where the stock is at. Select OK to that. And it face stop that operation. Go ahead and do a roughing operation from this angle to the OD of the part. And the same thing, I'm going to go ahead and use stock recognition. And I'm going to lead out the backside. Now I have to be careful not to go too far because I've got my collet right there. But I do want to extend it out a little bit. Just say 50 thousandths. And I'll say okay to that. I'm going to go ahead and use this tool to finish off as well. Might as well do a finish toolpath with that. I'll update that. So just like that, I have all my turning done. I have 6 simple operations. Now, let's show you some additional benefits for mill turn. This is obviously just, what you're familiar with in Mastercam. I'm going to hit the G1 button here. Now, in a standard mill or lathe, they'll take you directly to the post processor. With the mill turn, it'll take you to the IOF. It's our intermediate output format. I call it the intermediate output file. And this is where you can do all your syncing and any additional settings you may want for your G code. Let me drag this over here. It popped over here on this screen. I'm going to close some of these windows out. So here it shows you a quick preview. I've got a collet chuck on one side. Shows you the part. Shows you all the tool paths. All these little points are the sync points here. You notice as I pick on them, the other one matches up along with it. Here's all our operations here. Now I can expand these, and even in the pinch turn, if I click on motion, oops, this one here, it starts showing you all the sync codes that are ready for the pinch turn. You notice as I highlight on these over here on the graphical side of the window, it shows where those points are at. But I want to add some more syncs. I want to make sure that no matter what, these tools start at the same time and they finish at the same time. I can just click and drag and I can add additional syncs. All right. Let's go ahead, and I want to go ahead and say I want these two to start and finish at the same time, or at least start at the same time. I'm going to go ahead and save my settings. Go ahead and hit the launch button here. Give it a few minutes, and I'm going to launch the machine in my simulation. By the way, down here we have our timetable, and what I'm trying to do as I'm programming, I'm trying to avoid large gaps in my timing here. So if I don't have if I have a turret sitting around not doing anything while the other one's doing something, then I can look at my toolpath and say, how do I optimize all the motion of my machine to try to get, the best toolpath that I can. I'm going to close everything down. I'm going to leave my collision report open. I think that's pretty vital here. Go ahead and hit run for my simulation. Slow them down just a bit. It's going to go ahead and face it off. Then my lower turret comes over. Then it's going to finish up my turning on this side here. So you can see there's the back side of my parts inside the collet chuck. There's my rough stock, and that's what I have so far on this side. All right, that didn't take too long. Okay, we're just barely about 10 minutes into a presentation, and we've already finished all of our turning ops. So let's focus on milling ops. Again, I'm going to zoom in on this part right here, and let's focus on milling these flats. I'm going to go to my milling operations, and I'm going to use just a simple contour today. All right, I'm going to go ahead and go to solids, turn my face, and I'm going to go to just edges only, and I'm going to pick that edge right there. Select OK to that. Go to my tools. I have some tools already preloaded, again with prefixes, upper left, lower right, upper left, lower left. So I'm going to go ahead and pick my 2.5-inch face mill here. My setup is upper left, and I'm going to do Y-axis cross. For my lead in and lead out, it's going to enter in, come straight into the cut. And then for my parameters, I'm just going to use incremental values here. And I'll select OK to this. I'll backplot that. And then I can, so backplot is still, you know, same functions to get in Mastercam. I'm going to take advantage of that 45 degree on that face mill. Take all that in one pass for the presentation. All right. Now I'm going to go ahead and do all the other three sides. I'm going to do a toolpath transform. I'm going to do a y-axis cross, upper left, on this operation, and I'm going to rotate it. I'm going to rotate it 3 additional times, 90 degrees. I'll select OK to this. Backplot. There's my additional passes right there. So the way I program mill turn, and this is just, you know, now I'm kind of expressing an opinion of how I do things. I kind of look at this and I say, how do I want to see it on the machine? So while this is milling, while this tool is milling these flats, I've got a spindle over here that's not doing anything. It's just finished turning. So I'm going to go ahead and set up a tool to mill this side as well. So I'm going to go ahead and do a contour. Same thing. I want to pick that edge, spin this guy around like this. Zoom in here. And I'm going to pick that edge right there like that. Select OK. Select my next tool. So my lower right, my 1/2" end mill. On my setup, I'm going to go ahead and do a Y face, lower right. I'm going to do multi-passes. I'm going to do 2 multi-passes at about 3/8 of an inch. In an absolute mode, I'm going to go, my depth is going to be to the bottom. Top of stock will be at 0, and then I'm going to leave everything else the same. Hit OK, and I'm going to go ahead and backplot that. And there is my my tool path to mill that. And again, I'm not really, you know, messing with depth cuts and so forth. So once those 2 mill operations are done, let me focus on drilling these holes. Let me get rid of this. The turn profile keeps coming up. In the milling, we'll go ahead and do a simple drill. I'm going to go ahead and pick that hole, that chamfer, I should say, and that one there as well. So I got 425. Select OK to that. Again, I'm going to go back to the upper left, use my spot drill, and on my setup, upper left, and I'm going to do another Y cross. Actually, you know what? I'm going to do an axis substitution. I want this guy to rotate around. So for my linking parameters, everything incrementally here for now. My depth that I want to go to is I want to finish this to a diameter of 0.425, and it calculates my depth for me. So when I backplot that, it shows my spot drill coming around. All right. Now I'm going to drill the hole. So I'm going to say drill. That's a 5/16. Select OK to that. I'm going to pick the drill. This is on the lower left now. My setup is going to be lower left, a y-axis here. Let's go ahead and do a peg drill. And then we're going to go ahead and do our linking parameters. So my depth, I'm going to make sure that it passes all the way through to -625. And my top of stock, it's going to start off right at the flats of 0.5. My retract, we'll just make the retract 0.625 as well. And we'll go ahead and leave it at 1 inch. Select OK to that. And then we'll backplot. And we'll see that it's pecking as well. You guys do know that in the backplot, you can't set it up where it'll show the peck now, correct? That I think was a few releases back. I'm not sure or not. All right, good. So again, here we are, not too far into our presentation. I've got 11 operations. And essentially I have finished programming this part. It's that simple. So again, the way the mill turn environment sets up your tool, your planes, your axis selections and so forth, makes it that much easier just to pick geometry. You know, there's just all kinds of options you can do here. It sets a lot of things up for you, very, very automated. So now let's go ahead and go back to our IOF. Now it's not going to mess up all the previous syncs we did for the turning. It's just going to, oh, we have an error here. Let's find out what this is. 11 and 9, we have unknown errors. So that's another thing there too. Let's see what's going on here. Let's go to our, these tools are not loaded up. We got two number 4s here. So on my lower turret, I have a conflict, okay? So we cannot have 2 number 4s. One of these needs to be moved to another one. So on the flat end mill, let's just say the drill. I'm going to edit this tool. We have plenty of stations here. Let's make him tool number 6. I don't know how he became tool number 4. We'll finish this, right? And we should be able to load that and then right click, load that onto the tool as well. This is, while I'm here, you have the ability to view your turrets with all the holders in them. This is what'll, so if you have exact holders from your manufacturer, we can load these tool locators in, all right? That's all part of the mill turn environment. Okay, so I have another example that I'll show you here in a little bit. We'll go ahead and view the upper turret. There's my tools for this one right here, like this. All right, select OK to this. Now we can go to our IOF. All right, so for the turning, we already have all our syncs. So on the contouring, I want the contouring to start at the same time. Again, this is very visual. You just need to see what's going on. And then at the end of the milling, let's go back to this last contour here. I want these to kind of be synced up as well. And then for the drilling, I can get this opened up here. Since this is going to be spot drilling, this will be drilling the hole. We don't want this tool to start until the end of the spot drilling, like so. We'll go ahead and save this, and then let's launch our simulation. So here's the machine. Now we've added the milling tools to it. Let's run it through the verify again, or the simulation, I'm sorry. Go ahead and do a facing operation. Bring the lower turret in, do the pinch turn. And then while the left spindle is doing the finish toolpath, we're gonna finish up the turning on the right spindle. My play-by-play here, so at this, oh, we have a crash. We have a crash here. So this is one of the big benefits of using mill turn right here. So all this seems to be good right here. What's going on here? So if I click here, it takes me immediately to where the crash happened. So I have several crashes. So it looks like we don't have reach right here, and our lower stock is hitting the tail stock here. So I get these kind of questions a lot, and the first thing would be like, well, maybe we need to look, you know what? I just noticed something here too. This tool is too long. It's hitting the body here. So there's several things we need to do. One, there's end mill sticking out too far. So we need to shorten that. And it's crashing. I can get to it. Oh, it's running the whole simulation again. Sorry about that. We'll pause that. So we're looking at this holder right here. Now we need to get a holder that's extended higher up, and they do make them like that. The problem with that is then you do have to worry about hitting the sheet metal of the machine as well. I've got the machine turned off. So you can't really go too far or you'll be hitting the way down here, right? Looks like there's plenty of room. Now I don't have another holder. So how do we fix this? All right, let's go ahead and go back to our contour here. This is the face mill. And it has to do with the setup. Right now I'm using Y-axis cross. Nope, that's the wrong one. This guy here. I'm using Y-axis cross, my lower right, Y-axis face, I'm sorry. What if we change it to C-axis? So versus the tool moving around and the part holding still, we'll bring the part to the tool. What I also want to do is go into, so on my lower turret, my 1/2" end mill here, let's take this guy and I'm going to set projection. He's kind of sticking out too far. I'm just going to drag him down. Let's just say -1 inch for now. We'll leave him like that. Looks like there'd be plenty of room. We'll go ahead and go back into simulation. And and the main thing I want y'all guys to take away from this presentation is just how easy it is to maneuver through this, through the software, to be able to, quickly visualize the results of your selections on your tool paths, how easy it is to get back into the parameter pages, how things are maintained here. So you're getting an absolute verification of what's going to happen at your machine. Here we go. So we should have one final tool path. Well, not a final tool path here. We're not done just yet. Go ahead and hit the play button here. Just run through the whole thing. So again, I'm going to keep an eye on my, collision report over here. So far, so good. No collisions. Do all the turning. Then we're going to switch over to milling here. So right here's where we had all the crashes. But now we're doing C-axis motion. So the tool stays on the lower part of the spindle. And then the part rotates to it. So there was no crashes. And we also shortened up this tool so it's not hitting that lower turret or the lower part of the machine. Okay? So this looks all good. Now, one last thing as I kidded around yesterday in my dry run, my boss gets, he says there's just not enough operations here. We only have 11 operations. Well, we still haven't transferred this part over to this spindle. So on the turning, I'm just going to do a pick off cut off right here. And I'm not going to really change anything. Okay, we're going to get all these operations on how to take the part, pull it out, cut it off, park all this, the turrets and everything. Select OK to everything. It's going to come over, grab it, part it off. But now we got 25 operations. I've more than doubled my operations with just one selection here. For you guys that don't have mill turn, if you have using a standard post processor, this can be time consuming. So don't think that this product is for machines that have all these multi-turrets and everything. I have another example of a machine with just one spindle, and we do have a lot of customers that have single turrets, dual spindles. That's a very common configuration nowadays. And I'll call up a sample of that one here in a second. So here's the whole part here. We'll get and run it through simulation. I think I just have to add one more sync. We're going to go ahead and sync where we park the turrets. So we have this turret parked right here, and I believe we want to go ahead. Oops, we want to go ahead and sync this up right here. So none of this is going to happen until these two get out of the way first. Go ahead and save this, and then launch it. And I'm looking at my timeline here. looks like I've kept this machine pretty busy. All right, here's the simulation. All right, let's go to this simulation one last time on this part. Again, my focus is on the collision right here. Go ahead and run this. All right, so far so good, no crashes. Turrets get out of the way. Pull that stock out, part off blade, and then we're ready to do the next part. Look at that, no crashes. I like it. At this point, let's go ahead and post this out. This shows up in a dual stream. We can also align the sinks here. So as I scroll this down, right, it shows each of the operations. There's the pinch turning here, so you can see a lot of sinks going on for each pass. There's one-way code, right? So this does the finish pass. This is the roughing on the right spindle. We get into the milling, right? There's C90, 180, 270. Should be a back to a 0 here. This is milling the flats in the C-axis. We do take advantage of polar coordinate output if your machine has the ability. So G1 12.1 enables it. G13.1 disables it right here. Right. We're gonna spot drill, and then the drilling here, and then of course there's the part off right here. Right. Go ahead and close this down. So just like that, in a matter of about 30 minutes, and was me doing all this talking, you know, because I can't ever be quiet, you know. I've managed to machine this part. I had, you know, of course I didn't, you know, we didn't go through the steps of, you know, loading up the tools and loading up the spindles and so forth. That's another presentation right there. I just wanted to show you what the flow was like of how you machine a part, you know, take it from one spindle, transform it over, you know, work on your sinks, you know, verify it with simulation, output the code, verify the code, and then you should be ready to go to take it to a machine here. So on this machine, I'm going to go to levels. I'm going to turn everything else off. Oops, not that one. This one here. So this machine was just a generic, you know, mill turn machine that we use. There's an upper lower turret, right, with a stud spindle. All right. Whenever you use mill turn, there's always going to be a layer that has your machine in it. This machine is what we use for the simulation. And I've had guys come in here and run a session, and they delete this level out, and then when they go to simulation, it says, hey, it can't run simulation. If you ever get into that instance, just a quick little support. If you go to files and hit reload right here during your session, it will reload that machine back into that level, so that way you can continue on. And I've had a few guys do that there. Okay, so enough with this part. I'm gonna go ahead and save this. Then let's go ahead. I have another part here. This is from a part we did, I believe it was last year. We did another, oops, hang on a second. So this one here is for a single turret machine, all right? Same thing. I'm not gonna go through the toolpaths here. Just kind of wanna, you know, we'll go through the IOF. And again, it's just, you look at the part, there's really not a lot of syncing going on. For the single stream, that's probably going to be the only difference. Is there's really no need to do any syncing because you only have just one turret, all right? We go ahead and we launch this. And in this example, we have some additional holders. So this is a half index machine. Again, that's another common configuration we see nowadays. Guys are, upgrading their simple 2-axis lathes, and they're moving up to, live tooling to try to, optimize their operations. And also, a lot of machines now have what they call half index. Okay, so you've got your flats here. That's 5, but in between you got 4 and 6. And we can also have these tools, these multi-station drill type holders. Here's a holder that holds 4 tools right here. Okay, so this can be tool number 2, tool number 4, I forget what it is. Let's go ahead and run the simulation on this one. Oops. Go ahead and hit run. So this faces and turns, and without doing a turret index, so it's going to come over and then work on the left spindle. Then it's going to go ahead, and I've got it going back to a home position here just for the demonstration. You can, in the IOF, designate whether it moves away from the part or stays close in. You can just say none. Excuse me. So here's our spot drills. Again, do a half index. This does some drilling. And here's some milling. Now, I don't know why that crashed. Oh, I think I know why that crashed. The flute description on that tool, the depth of cut is deeper than the flute right here. So that's what that crash is right there. So we could just go change the definition of that tool. So we can even do high-speed machining. That's one thing I did not do in the previous. There's some high-speed machining here, right? We'll do some spot drilling, and then drill some holes. And then everything, the turret should go and park away with the transfer. So it ejected the part. Go ahead and grab, pull this out. And then we're going to go ahead and part it off. There you go. So there's 2 quick examples. One was using a full, multitasking machine, upper lower turrets, dual spindles. And here's one with a dual spindle and a single turret. Oh, you know what? Let me check this right here. The in-process cut. I would say that, yes, that is what's going on here. My flute stops right there, so I'm hitting the shank. So we could just go, adjust the tool, and then we could go ahead and get rid of that cut. So it checks everything. I think there was a question about whether it hits shows collisions with the machine housing. Absolutely. It checks collisions for just about everything. If it's not working right. If you define your tool wrong, I've seen this a lot now. Guys are bringing in, now that we can do 3D tools, they'll define the spindle direction in the opposite direction of what the tool looks like in the machine. So you'll have insert facing up this way, and then the spindle coming around, in this direction. So it's not right, and you'll get that error as well. You won't see it in backpot. Backpot will say, hey, it looks good. All backpot is looking for is the 2D profile of the part to make sure that the shape of it doesn't interfere. In the simulation, we're looking at way more than that. If you have a through coolant hole, if in the previous presentation, I don't know if you noticed or not, but I had tools in there with little coolant nozzles, and if those would have hit something, then we would have, been able to see that collision happen.